This is going to be a tutorial on how to solder the Evil Mad Scientist Simple Relay Shield. This is a great kit for beginners because it has an outline of each component on the board. First, start by setting your soldering iron to about 500 degrees Fahrenheit. Start by wetting the sponge of your soldering iron, then cleaning off the tip with the sponge. It should make a sizzling sound. If it's not sizzling, then your soldering iron is not hot enough. After you're done, we're going to begin tinning the tip of the soldering iron. The tinning is essentially just coating the tip of your soldering iron with solder. After you're done tinning, you can once again wipe the tip of your soldering iron on the sponge. The tip of your soldering iron should look metallic.
It's time to begin soldering.
First, we're going to begin with the 1K ohm resistors. These resistors are going to be installed in location R1 and R2. First, we locate location R1 on the board. You'll see an image of a resistor on the board. Resistors, the polarity doesn't matter. There is no polarity. So you won't be able to get them backwards. First, we start by placing the component in the holes. You won't be able to see, but I'm bending the leads of the resistor underneath the board. This makes sure that the resistor doesn't fall out when I flip the board. I'm not soldering the contacts on the side of the board that the component is on. Instead, I'm removing the board and flipping it. First, you start by placing the soldering tip on the component lead and the contact. You want to try to heat both of them up. Now, you place the solder in between the soldering tip and the component lead. You want to heat up the component lead. You do not want to be carrying solder that's already heated to the component lead. Although it may seem like it works, it makes for a bad electrical connection. We will repeat the same process on the second contact. Once we are done, we can cut the leads to the component. We have just soldered our first component. Now, flip the board back over. I just installed the second resistor. Once again, I'm bending the leads underneath the board. Each time you take the iron out of its holder, it's a good practice to wipe it on the sponge. Once again, place the soldering tip in between the component and its contact, and let the solder flow in between the two. And for the second contact, be careful on this one to not interfere with the contacts you've just done. If you misplace your soldering iron, you may mush the two contacts together. In this case, you'll have to use a desoldering tool. Once again, we will clip the leads to our resistor. Two of our components are now soldered. Next, we will install two diodes. Diodes do have polarity. It's important to make sure the stripes on the diode line up with the picture on the board. The diodes will go in D1 and D2. First, I bend the leads to my diode, find its location on the board, make sure the stripe matches up with the picture, and then bend the leads back to the board, just like we did with the resistors. I'm going to skip ahead and install the second diode, so I only have to flip the board over once. and push the component down. Once again, fold the legs of the component back to the board. Once again, unlike resistors, diodes do have polarity. Ensure that the stripes are lined up correctly to the board. If you install it backwards, you'll have to use a desoldering tool to remove the part. Place the soldering chip in between the lead and the contact. Push the solder in between and let it flow. Ensure that your joints are shiny and silver. If they're dull and gray, you have what is called a cold joint. The electrical connection in between the component will not be good. In fact, it might not work at all. Repeat the same thing for the second. Repeat the same thing for the rest of the contacts. It's important to make sure that the solder is flowing naturally to the contact and the lead. If it seems like it's all bulging up around the tip, you can give it a little bit more time to heat up. Otherwise, your tip may be dirty. Either clean it or replace it. See, at first, it all congregates around the tip. Once I leave it there long enough, it automatically flows to the contact. Use a pair of clippers to remove the leads to the diodes. Next, we will be installing the LED. LED stands for light emitting diode, so you can guess that it has polarity just like the diodes we just did. The LED will be in position D3. Remember, the two diodes we did were in positions D1 and D2. The longer leg on an LED is the positive leg. Be sure that you are installing the long leg in the square hole. Bend back the leads to the component. Sometimes you need to wrap the leg of the component back around the board in order to make sure it stays in. Once again, if you're properly heating both the contact and the lead, the solder will naturally flow to them. There are two capacitors in this kit. This is an electrolytic capacitor. One of the legs is clearly longer than the other. Just like the LED, the longer leg is positive and the shorter leg is negative. Polarity does matter for the electrolytic capacitor. This is a ceramic capacitor. It is orange and has two legs of equal length. The polarity of this capacitor does not matter. That means it can be installed in either orientation.
The ceramic capacitor goes in C1. Much like the D for diode, C stands for capacitor.
Because the polarity does not matter, I can either install the capacitor this way or this way.
Once again, the polarity of the electrolytic capacitor does matter, and the long leg goes in the square hole. When you are finished installing the capacitors, bend the leads to both of the components back towards the board and flip the board. Once again, as you solder, place your soldering iron on the contact in between the lead. Heat up both at the same time, and then let the solder flow in between the two and naturally attract itself to the contact. Next is the transistor. It goes in location Q1. Make sure the flat edge of the transistor is lined up with the picture on the board.
Solder it like we have all of the other components. Start by wiping your soldering tip on the wet sponge. Put your soldering tip in between the contact and the lead. Slowly put in the solder. and wait for the contact and the lead to pull it in. This part might be a little tricky. With a shield, it's important that the headers line up with the Arduino. Usually, we'd put the board and the headers inside of an Arduino in order to solder it. Unfortunately, these are stackable headers, which means we can put another shield on top. What this means is we cannot access the other side to solder it. The easiest way to solder it from here would be to place it on a table. Try to make sure that all your headers are lined up correctly on the table. This might require some adjusting. You might need to unsolder one or two of the headers in order to make sure they line up correctly. Once you think you have it in a good position, start by soldering the first and the last pins of every header. Just like we did the leads. Place your soldering iron in between the header and the contact and wait for the solder to be absorbed. What we're putting on now is essentially like a tack. We're testing to see whether the headers actually line up soldered like this. If they don't, we will only have to unsolder one or two of these pins for each header. If we went ahead and soldered every single pin on the header, we'd have to unsolder every single pin in order to realign them. Let's test to see if it fits. Place the shield on top of the Arduino and press down. Mine fit on the first try, but I have some more experience than you.
If yours didn't work, you're going to have to unsolder the pins that you tacked down and try to align them correctly.
Because all of mine did work, I'm going to continue and solder the rest of the pins. You should start to get into a flow of how to solder each pin. Each pin should not take you more than a second or so. Relay.
Next, we are going to solder the most important element of the relay shield, the relay. It can only go in one direction, so you can't get it backwards. Place the relay in on top of the shield, and flip the shield over. We're going to solder it just like every other element we have soldered.
Place the soldering iron in between the lead and the contact, and let the solder flow in between the two. We only have two components left. The first is a terminal block. This will allow us to connect wires to our relay shield. Sometimes things are easier to solder if you make little assisting devices for yourself. Simply flipping it and putting it on the table won't work because the relay is higher than the terminal block. I'm rolling electrical tape in order to make a pillow for the terminal block. This will allow it to stay in place when I flip the board and put it on the table. Now, solder the terminal block like we have every other component. Once again, if a contact looks dull, simply heat it up to reflow the solder. Make sure that you're covering the entire contact and you have an even dome shape. Again, if you don't have a dome shape, simply heat up the solder once again. We only have one more component to go. This is a 0 ohm resistor. That means it has no resistance. It might seem a little silly, but it's pretty much just a jumper. This jumper allows us to make a selection. You won't really need to worry about that selection right now. Because we only have one more component, I won't bother with putting it in our third hand. All done. Clip the leads, and we're finished. I hope you enjoyed, and look out for more tutorials coming soon.